Okay, hello everyone. I hope you all are doing well. A warm welcome to the Expert Edge Masterclass brought to you by Shine.com. We are really excited to have you join us today for this session where we will explore building a scalable web application full stack and gain valuable insight that can help you enhance your skills. Before we dive into this session, let me introduce myself. I am Preeti Dagwal and I'll be your host today. I assure you this session will be packed with valuable insights and practical knowledge that you can apply in your work. Now, let me introduce our speaker for today, Mr. Ishant Kumar. Ishant is a Java full stack developer, mobile for development expert, and an entrepreneur with extensive experience in the tech industry. He worked with Samsung Electronic R&D Center as a lead engineer, developing Android application and gaining international experience at Samsung headquarters in South Korea and Canada as well. He has also trained professional at Amazon R&D and JP Morgan with expertise in cloud computing and modern technologies like Docker and Kubernetes. He helped businesses optimize application deployment. With such impressive background, Ishan bring a wealth of knowledge to this session. I encourage all of you to engage, ask a question, and make most of this learning opportunity. Without further delay, let's welcome Mr. Ishant Kumar to lead to today's session. Over to you, Ishant.
Yeah, thank you, Preeti, and thank you to Shine.com to give me this platform as well. And good evening and welcome everyone. So we will be having a discussion on understanding what is meant by scalable web application development, right? So whenever we are talking about the web application development, so typically any other application or a software solution which we want to design or develop. So it involves two parts. One is the front end, another one is the back end. And collectively, we have a stack. And you guys may be aware of what is the mean stack, what are the MERN stack, and the other contexts available with respect to Python or Java stacks. So our today's agenda is to understand how the solution can be developed in a way that we can write scenarios which can scale with ease whenever we have the traffic coming onto our solutions. So I hope all of you are able to hear my voice, right? We are all good to go. And Preeti, do we have in between Q&A session or it's just gonna be in the end?
In the end.
Okay.
Yeah, if someone have any query or any question, they can write it down in Q&A part. So after 45 minutes, we'll start that.
Good to go.
Okay.
Guys, let's get started. So I'm just gonna share my screen so that we can proceed accordingly. All right, I hope the paint screen is visible to everyone.
Yes, it's visible.
Okay. Now, before I start my presentation, we need to understand something known as web application. So web application typically has a front end and a back end. So a typical example can be like what, right? That you are writing a front end based on some JS technology. It can be React, right? And the backend can go like the Express running on your Node.js, right? The other way around, we can even have React as front end, and in the backend you can use Python, you can even use Java, etc., and etc. Right? So we have a lot of things coming up. And of course, when we talk about the backend typically is the guy, right? So who has microservices, right? And they are pretty much in communication with your database. And when we talk about database, it can either be SQL or it can be no SQL, right? Nowadays, we have MongoDB ruling the industry when it comes to the NoSQL database. And when it comes to the SQL, right? So we have the leader known as Oracle, right? So let's say if you are doing a transaction on Swiggy or Zomato, so what exactly is the database which is recording that transaction? So it's Oracle. And even for the banks and any enterprise solution, Oracle is top-notch product. Okay, so this is a very quick introduction that if we are writing a web application, and the similar thing for the mobile application. So we have this kind of a stack coming into the picture. Now, the term here to understand is something known as scalable solution, right? So what is meant by scalable solution? Let us take a scenario as an example. When we are using the e-commerce platform like Amazon or Myntra, so in regular days, it is perfectly fine that they're handling some number of users, right? Some number of active users. But the moment there is some Republic Day sale coming up, or let's say Myntra puts up an end of reason sale, right? So at particular days of that timing, right? So we have lot of traffic coming up to the same backend or the front end, right? Now, this is where the companies, they are looking forward to have a solution which can scale automatically, right? So my backend should not crash, my front end should not crash. And in the very initial timings, right, when we used to use Myntra or Amazon for the e-commerce, this sale kind of a solution, the application would hang a bit, and they would have created a pipeline kind of a scenario, okay, that few users can enter into the sale, not everyone, right? So they implemented all those kind of things. But nowadays, right, so we have wonderful technologies coming up, and they can be implemented so that we can write a scalable solution. So the term scalable is always a challenge, right? So I'm writing that scalable thing is what industry faces as a challenge, and we'll try to understand what can be the solution. So moving from here, my next discussion is to make you guys understand the term deployment. Deployment typically means that you have your software solution, and this solution you are going to in a very layman term, right? So you're going to upload on server, right? So that's what a deployment typically means, that your solution should go live. So it should be uploaded on some server, and this server is accessible through various clients, and your solution is acceptable and accessible on those machines. And when I say software, it can be web, it can be mobile, right? It can be even the interactive one. For example, we have Alexa and all coming up, right? Etc., etc., and etc. So the deployment has three eras now. The very first era is referred to as traditional deployment. And the second era is virtualized deployment. And the third era is containerized deployment. So industry still has the projects which runs using the traditional deployment strategies, right? And the companies, they are practicing the virtualized deployments. But nowadays, when we talk about the modern technology stacks, right, or the modern deployments, so containerized deployment is something which the companies are looking forward. So when I have written in our previous discussion that the challenge is the scale, right? So how we scale the solution? So the answer typically comes from here, right? So if we have containerized deployment, right? So this gives us an edge to scale. Okay, so we'll understand how exactly is this going to work for us. Now, let me show you one example of traditional deployment and how it has worked in the industry. Then we'll talk about this virtualized deployment. Then we'll understand how containerized deployment is going to help us with the scalability thing. So for this, I'm just going to quickly open a traditional application, let's say the Java application. Okay. So in the traditional deployments, what we have is we have some projects, and then what we do is we create a distribution build for these solutions. Now, if you look at, I have one project, and if you notice that we have this jar file by the name of pms.jar file. Now, this is the solution which we need to just upload on the server. and run this jar file, then this becomes accessible to the clients. So in traditional deployment, we have something known as a distribution solution or a software in some form, right? So if I talk about Java, it's a jar file. And if I talk about the Node.js technology stacks, then there is a distribution folder which gets created when we do a build. Now, how we go ahead with it, right? So in a local environment, so consider this is my local environment. Right, so here I am running this command, let's say java-jar, and this is how I will say pms.jar. So one single command will simply bring up your server, your application, right? And on a particular port number, your application will become accessible. Now over here in this particular scenario, my application is accessible at port number 8080, and there is a Tomcat server which is involved over here. So coming back, let me quickly open the Chrome browser, and I'm going to say localhost 8080. You can see that there is a solution which is up and which is running fine. So this is kind of a traditional deployment. Now I'll try to draw an architectural diagram to understand you guys what is meant by traditional deployment. Okay. So in traditional deployment, we have a high-end computing machine. We refer it to as a server, right? So this is my high-end computing machine. And this typically is referred to as a server, but server is not generally a term associated with the hardware. So server is generally related to your software. Now, on your computer or a high-end computing device, we have a layer known as operating system. And on the operating system, we have this another layer known as the server software. So here we have this server software. Now I'm typically trying to talk about this part over here, which I have shown, right? That my application is up and running fine. So how did it come up, right? I just executed a command known as java-jar, right? So this was my command. So in a traditional deployment scenario, what we will do is we'll ensure that this server software, I'm just talking about this stack, which we are as of now discussing is Java backend, right? We'll also try to see the node thing. So if it's a node solution, then it is supposed to be the node coming up here, right? Rather than the Tomcat. So in Java, it's Tomcat, right? Now, on my server software, what I will do is I will deploy or upload my application. So this is going to be my application. So this is my jar file, right? So pms.jar, right? So my solution or my application is running on this high-end computing device, right? So this is my solution. Now, when I'm using the term software solution or application, right, please try to understand it from the higher end. So I'm not talking about the front end or the back end. I'm also talking about the entire solution. It can be front end alone, it can be back end alone, or it can be both. Now, what exactly is the problem here? Now, whenever I will execute the command java-jar some pms.jar on my high-end computing machine, right? So why we call it a server? Because it has a server software running on top of it. Now, this server software, whatever is running, right, it has a port. Okay, so it has a port. So let's say the port of this server is 9090, or maybe it's 3000, right? Or maybe it's 8080 in our case. We have configured it from the code itself. So if you want to access this application, you need to have the IP address of this server. So consider that there is some IP address 198.x.x.x. Then you say colon 8080, right? So this way, if you are sitting at your home, maybe on your device, which can be either a computer or it can be even your mobile device, right? So you will be able to access this PMS jar application using this concept, right? So this era is referred to as traditional deployment. Now, what exactly is the problem here? So we will talk about the challenges here now. Because since we are discussing and we are trying to understand. Okay, so just give me a moment. Now, since we are trying to understand that the world or the industry moved from traditional deployment to virtualized deployment and then to containerized deployment, right? So, and we are understanding and we are trying to hit this term known as scale. So what are the challenges when it comes to the traditional deployment? The first thing is that whenever I am deploying an application, so if I deploy other application on the same machine, right? So there is a challenge of resource utilization. Let's say I need to create and deploy another application, right? And this application which I am doing, it can be the same technology or it can be the other technology as well, right? So there are these two applications, right? So application 2. So there is resource utilization issues. There may be a scenario that application 2 is accessed more on the same machine. So application 1 can underperform. So this is one challenge, right? One problem. The second problem is, what if the traffic increases? Now, as a software company, you don't know when the scale will come on your solution, right? So as I said, we are just considering a scenario on the end of reason sale or the Republic Day flash sale, right? So at that particular instance of time, the traffic will be increased. So there may be weekends where the traffic can be increased, right? So the company can do a prediction, but you never know when the traffic will go up or down. And there are times when the traffic is very low as well. So the scale is something which is the another part, right? Now here in traditional deployment, what companies will do is they will invest in hardware. So they will invest in the hardware. Now, when they invest in hardware, they are bound to get a high-end computing machine. I'm just giving an example, right? So let's say 16 GB RAM. So they are investing in 16 GB RAM. Ideally, it's going to be very different configuration, right? So they invested with the computer having 16 GB RAM. And suddenly the traffic has increased. So your machine is not performing in a better way. So what companies would do, they would invest in some really high-end machine. I'll just give you an example how. So let's say AWS EC2 instance types. So just to have a fair understanding what I'm trying to put across. Okay, so what you would see that there is some medium machine, right? It has a 4 GB of RAM with one CPU, right? And this list keeps on moving ahead. So we got this metal with 192, 768. Now, as a company, if I am unaware about the scale, it means I need to invest in hardware. And I will be paying the bills for no reason when my scale is very less. And there can be a problem when the scale goes high, right? So having said these issues, then there's a company known as VMware which came into the picture, right? So VMware said that we'll try to resolve a few issues. And VMware introduced a technology known as virtualization. All right, so they said that, okay, we'll bring a term known as virtualization and we'll try to help, resolving these problems or challenges. Now, the same thing we'll try to understand in a virtualized environment, right? So from first step, traditional environment, now we are moving to the second step, which is our virtualized environment. Okay. So once again, we have a high-end computing machine. So there is a high-end computing machine. And in this high-end computing machine, just like we have this operating system, so same way we have the operating system on this machine as well. Then on top of your operating system, we have another layer coming up, and this layer is referred to as your hypervisor. So this is where virtualization comes into picture. And when we say virtualization, so we are trying to divide the machine into multiple machines in a layman language. So what I'm trying to put across, that I got one machine here and the second machine here. So I can have multiple machines derived from the same machine, and we call it a virtual machine, right? So VM1 and VM2. Now VM1 and VM2, they are running independently. Okay, so the different applications are running in different environments, so there is no resource utilization issues. So we can configure the resources for VM1 and VM2. So my application will typically run over here, and similarly the second application can run here. And another good part is what, right? So my VM1 can be a Windows machine and the VM2 can be a Linux or a Mac machine. So we have an option to configure these machines, right? So what challenges VMware tried to solve here? And this era is referred to as virtualized deployment. So they try to solve the challenge of resource utilization, right? And also when it comes to the scalability, so they had this option of you can say vertical scale. Now what is meant by vertical scale, right? So vertical scale is typically what AWS has shown us over here. Now when as a company, right, I am going to come up and start my solution. Let's say I'm a startup, right? I have few users. Then I can start with the medium scale, right? I can choose a very small instance. As I move up with my audience, so what I will do is I will slowly and slowly keep on incrementing the resources, right? I can go to a 32 GB RAM, right? So on and so forth. So this is known as the vertical scaling, right? Which we are trying to do. So in terms of our virtual machines, we can go ahead and we can do a vertical scale. But once again, right, if I'm working with the vertical scale, it means there is an effort involved. Of course, we have automation nowadays, right, into the solution, that the resources can be managed in a way that scale happens automatically for us. But for vertical scale, or if it goes up or down, right, so we have to work accordingly. Okay, and this way we are also trying to understand that there is load on single virtual machine. Now what I'm trying to put is that if there is my application known as pms.jar, so if this application is running, right, so it is typically running in a single virtual machine and we have kind of a single failure, right? If my application crashes or if there is anything a problem, right? So scaling is secondary, right? But I have some other challenges which are also evolving with time. So after this, finally, we have containerized deployment, which we say the modern deployment, right? And it typically works around the concept of scale. Okay. So let us see how it's going to come up now for us. So once again, we have this similar structure. I'll just quickly get it from here. Now we are talking about something known as containerized deployment. So this is our modern day stack, what we use. So we got containerized deployment, which currently industry is working on, right? So if you are going to work with the companies, so this is one important skill to have, right? So we are not as of now working in traditional deployment era or a virtualized deployment era, right? So yes, of course, the startups, they use the virtualized deployment concepts, right? But when it comes to the MNCs or when it comes to the companies which are enterprises, so they are meant and they are bound to use containerized deployment because they need to manage their scalability concerns with ease. So in the containerized deployment era, so we have a container runtime instead of the hypervisor layer. And this container runtime, the biggest example is Docker, right? So this guy Docker is one big example. Now, on the container runtime, you have something similar to your virtual machines, or you can say these are the lightweight virtual machines, and we call them as containers. So there can be multiple containers which are kind of running on your same container runtime. So container runtime is capable of handling these multiple containers. So my application 1 can run in container 1, my application 2 can run in the container 2. So it is solving the same thing which VMware is doing, right? But it has few other important things which it highlighted. So some positive points here, the challenges which this guy has solved, right? So resource utilization is something which is taken care of over here, because every container will get their own memory and they can function accordingly, the configuration which we'll give them. Then after the resource utilization, we also have the problem of scale, and this is also resolved. And the above all, right? So we have containers which are lightweight. This is very much important, right? So they are not much heavy when it comes to the computing end or the memory end. So in the containerized deployment, containers are not just only one thing which are solving the solution for us, right? So we have one more technology stack coming into this containerized deployment, and that is referred to as Kubernetes. Now, this is where we actually have the solution done when we are talking about the scale. So what Kubernetes is, it is actually helping us to write a scalable software solution, which can be either in the form of web, or it can be a mobile, or any type of solution which is going to be scaled in future. And we need to pretty much also save our expenses on the cloud computing infrastructure. So let me show you what exactly Kubernetes will do for our scaling part. Now here in Kubernetes, we are going to have a distributed architecture coming into the picture. So I have a master node, which is a high-end computing machine, and there we have these worker nodes, right? So these are also high-end computing machines, but we can configure them as per our requirement. Now, this is a fusion. When we are talking about Kubernetes, it's a fusion of something known as the virtualization as well as the containerization, okay? So solving the scale. So solving the scale typically involves two things: virtualization plus containerization, okay? Now, over here, we have these 4 virtual machines. So this is our virtual machine 1. This is our virtual machine 2. Then I got my virtual machine 3 and virtual machine 4. Now VM1 can be, let's say, 16 GB. I'm just taking an example of memory in terms of memory, right? So this can be a 4 GB guy. This can be an 8 GB guy. This can again be a 4 GB guy. So this is all up to us, right? So how we want this infrastructure to come up. So master node has, so we are trying to understand on a very higher level as per the timings, guys, right? So that you get a fair idea. So master node is the one, right, which is kind of controlling these worker nodes, right? And worker nodes are the one where my application is going to run. So what we do is we containerize the application. Okay. So when we create the containers in Kubernetes, every worker node is running your container, and the terminology over here is referred to as the pod. So just give me a moment. Yeah. So what we have is we have this guy known as the pod. So here we are with the pod. Okay. And there can be multiple pods on the same worker node. And when I'm talking about the worker node, guys, it's a machine. It can be Windows, Linux as per our requirement. So in the pod, we have the container runtime. Okay, so there can be this Docker configuration, right? And on top of your container runtime, what you have is your application. So this is my application running as a container, right? So pod is basically a hosting environment for your container. Now my same application one is running on multiple worker nodes as the pod. And of course, guys, there can be other pods available also, inside which there is some other solution which is also running. Okay. So there can be multiple pods in the same node as well. So over here, how the scale is getting answered, right? So that is important for us to understand. Now, as in, if you look on to this structure, you understand that we can access the same application through three different machines. Where one machine was handling, let's say 100 users, here three machines are handling the 100 users, right? So the load is divided over here. Moving ahead, if the traffic increases, we simply keep on adding the worker nodes in this distributed environment, right? And this is pretty much automated when it comes to the Kubernetes. So we have something known as horizontal scaling coming into the picture over here, right? So this is what is important for us to understand. Now, as traffic increases, we can increase the number of nodes in our solution. And if the traffic decreases, we can decrease the nodes in the solution. And accordingly, my billing in the cloud is also getting optimized for us. So guys, this is a perfect scenario if you are trying to deploy specifically your solution which has a microservice architecture. Now, when I'm talking about the term microservice architecture, I hope you are all aware of it. But if not, so just a quick introduction, right? So in a microservice architecture, what we try to do is we try to write your service is nothing, it's a code, right? It's a solution file where it is catering a particular kind of a job. For example, the payment service, which will only do the transaction related job, right? It will not do a user authentication thing. So user authentication service can be another microservice. So we divide the project into a microservice architecture, typically the backends, right? So that my entire project should not go down if any service is down. And we can deploy multiple microservices on different worker nodes. So there will be multiple instances of the microservices available, and your solution will very much and pretty much handle the scale. Now, for an organization, if you need to have, let's say on an organization level, there may be multiple projects. Now, for multiple projects, they cannot think of writing this Kubernetes architecture for every single project, right? So there has to be some automation. So we have another solution in industry that is referred to as Pivotal Kubernetes Service, right? So this is referred to as PKS. And this is majorly for enterprises which have multiple projects to handle. So this PKS is basically automation on Kubernetes, right? So Kubernetes is going to have automation for scale, right? So we have some configurations through which we can have automation on scale, right? And this automation is pretty much an easier way to understand through two configurations. One is a deployment.yaml configuration, other one is a service.yaml. So there are these two configurations which we do in Kubernetes architecture. So guys, this is how we are trying to understand that there is a traditional deployment, right, which won't work for us nowadays. There is a virtualized deployment, right, which is pretty much an outdated thing. Then we have a combination of both, right? So combination of virtualization and containerization is solving the problem of scalability, and that is through Kubernetes or through PKS, right? So PKS is a product by VMware itself. So it's an enterprise product, right? And Kubernetes, of course, is ruling the world. So guys, this is how we need to ensure we need to incorporate the skill called containerization and the skill called Kubernetes in our skill sets so that we can have our resumes presented in a better way. Okay, now I will move ahead and try to share you a certain insight on how we can. So there are step-by-step things, but in this particular amount of time, what I will try to show you that there is a front end and there is a back end, right? So how you can at least Dockerize them, and then you can prepare them so that you can move ahead towards deployment on the Kubernetes architecture. Okay, so just give me a moment. Okay, so I just hope that the screen is visible to all. So
Yeah.
what I have is I have these two different projects. One is my React application. So it's a front end solution, right? So if you see, we have various node modules configured, right? And we have written this entire source code here and there. And for this, it's basically how you can rent out the things, right, on the platform. Then there is a MongoDB Django backend for the project, right? And here we have this MongoDB backend for the project. So we have written these various different API endpoints as the project. So what we will do is, for my Kubernetes to come into picture or my containerization to come into picture, we need to follow a step-by-step approach, okay? Just give me a moment once again. So the first thing first is where you containerize your solution. Either it's a front end or a back end. And in order to containerize your application, you need to create a Docker file in your project. So Docker file is a way how you can create images. And once you have created the images, thereafter you can run your images as containers. Okay. So if you see here, when I'm trying to containerize one of my React projects. So the base image is this Node 14. Now Alpine is basically an official base image, which is a lightweight image. Then I'm creating a working directory known as /app. Then I'm copying the JSON file in my application, and I will simply run the npm install command. So the npm install command is going to come up and install all the packages as listed in my package.json file. Then I'm going to copy my code into the working directory, and then finally say run npm run build command, which is going to build my React application. So we'll expose the port 3000, which typically means that my solution is accessible at port 3000. And finally, the command npm start, which typically is going to start my application inside my Docker container. So this is the configuration of my React project when I have to containerize it. Similar to this, what we have is we have our Docker file for the Python project. Now for Python, I got the base as Python 3.8 where I'm going to work. So here what I have done is I have just introduced some other commands to understand. For example, we have created an environment variable so that we can set up a directory path. Then we are going to make a new directory rather than just creating a work directory command, right? So we are selecting this work directory as Docker home. So this is how you can utilize environment variables. In case of Python, in order to install the dependencies, you need to say pip install and then upgrade the pip. And finally, we copy the entire solution and then install my requirements.txt file. And then here we are exposing the port 8000. In order to start your Django server in the backend, you need to say command python manage.py run server and here on the port 8000, right? So 0:8000 typically means on the localhost we are trying to run the file. So guys, Dockerize is something which is as such the first step, right? So you have the solution with you. What you need to do is you need to Dockerize the solution and then you need to make it ready for your Kubernetes. In order to make your solution ready for the Kubernetes, what we have is we have two configuration files to work on. The very first configuration file is referred to as service.yaml. Now the service.yaml, we are going to define the object in Kubernetes as service, and then we give it a name, and then we give our ports on which my application is going to run. So typically the type of service is node port, which typically is that your service is going to be giving you an access to the application on this particular port number 3000. So real configuration comes into the deployment.yaml file where you mention your container image. And if you see in this specs over here, we will mention that there is a container and you can pull this container from the Docker repository directly, right? So rather than you creating the containers locally, you can push your container images into the Docker hub and then you can pull it. Now, Kubernetes will pick up this deployment.yaml file. It will understand that this is where is my image residing and then run this image as a container over here inside a pod. And the service guy is giving you a way to access this application running inside the pod. So guys, this is typically one of the ways that how we can move ahead and utilize the concepts of Docker and the Kubernetes, the concept of virtualization to scale your solutions. So yes, this is what we have. I hope in this pretty much particular time, I have just, kind of given you the right input. And now we are open for Q&A.
Yeah, so I would like to request everyone, if you guys have any questions, so write it down. And I want to request you, I am opening poll to just fill our feedback form. And do write your questions as well. So we have very first question is, if in interview we are asked what does the master node actually do, how do we respond? Should we say it is like a load balancer?
When we talk about the master node, right? Let me try to give you one simple answer on this. So this is more clear when we talk about in a better way. So on the Kubernetes, you would find the documentation here, right? So I'm just gonna say even more better Kubernetes architecture. Now, I can't draw much, but in order to make you guys understand or just to respond to this question, so this is exactly your answer over here, right? Now the master node is referred to as the control plane. And if you see, the control plane is kind of managing, or you can say your worker nodes, but they have certain key elements defined within them. So we on a high level can say that yes, master node is kind of managing the worker nodes, but there are, for example, we have this kube scheduler as a service running in my master node, right? So the main role of this guy is that it has to schedule which solution goes on which port, right? I mean, which container. Then this is kube API server. This communicates with your worker nodes, right? So just don't give a high level answer. So you can refer to this particular link. I'm just gonna share it over the chat so that you explain it in a more better way, right? Just not a simple key definition. So draw this architecture, and every single definition of what is what, right, is already mentioned here for all of you, right? What etcd will use, do it's gonna be a key value kind of a storage mechanism, right? So everything is listed here. Try to understand it in a deeper way and then answer it properly.
Okay, so next question is, what key skills should I focus on to land a job in scalable web application development?
So now the first thing is that you are looking forward your career as a web application developer or a mobile application developer, or you are trying to look forward towards the DevOps approach, right? So there are these three verticals now. If you need to write a web application, so you should focus on full stack developer. It means you should be able to write a front end as well as a back end. And when I'm talking about the scalability scenario, right? So here we are introducing Docker and the concept of Kubernetes into the picture. So this is pretty much also related to a field called DevOps. So in the industry, you have these small steps to move ahead. You can't think that I'll go ahead and consume these three. So there is some sort of experience also required that I reach up to that level. So initially, if you are a fresher, you need to begin with full stack developer portfolio. And as in you get some hands-on experience, maybe an year experience or a two, then you move ahead with the Kubernetes, right? So this is a step-by-step approach.
Yeah. So another question is, can we go for Spring Boot for backend development?
Yes, so Spring Boot is one of the top-notch choices. Now, as I said, for enterprises, the solution is typically in the form of microservices when it comes to the backend, right? And Spring Boot is the top trending technology which any enterprise will opt for in order to develop a robust, scalable backend. And if you pick up any bank, right, so you would see that the Spring Boot and Oracle combination will come into the picture. Of course, in a new age startup, we have mean and burn stack, but when it goes to a scale, right? So I'll give you an example now. Let's say I'm doing transactions on Swiggy, right? So some guy is doing a transaction of $100, someone is doing 300, someone is doing 1,000. So how the payments should be settled into Swiggy's account,
The security article नहीं दिख रहा.
right? So all these kind of things are pretty much taken care by Spring Boot and the
Copy
Oracle
because
kind of
sharing हो
concepts.
सकता है. कर दो click.
Yeah.
Okay. So how can I scale the number of pods in deployment manually, and what are the options for auto scaling?
Yes. So for this, the simple thing over here is where you need to work on your deployment.yaml file. I hope my screen is visible, right? Guys, screen is visible or not?
No, it's not visible.
Okay, just give me a moment. So to answer this question, right? So if you see in my deployment.yaml file, I do have replicas mentioned over here. So this is my specification that how many replications I want, how many pods I want, right? So this will actually go ahead and enable 3 pods, right? And it's gonna run your container in 3 different pods. Also, you can anytime change this YAML file configuration and you can reapply the configuration. And then with the kubectl, you have various commands also to manually change your replicas and do a scaling. So this is how the auto scaling can be configured. Yeah.
Okay, so does SRE related with Kubernetes? If yes, please explain how.
Okay.
Hello, am I audible, Ishan?
Yeah, just give me a moment.
Okay, okay, okay.
Okay, I'm just gonna share my screen once again. I'm so sorry. Now, to answer this question on SRE, right? When we talk about the term SRE, right? So SRE is a set of principles when it comes to the industry, right? So it's like your site reliability engineering thing. Now, of course, whenever you are working on the DevOps field, so SRE will always have a correlation to the technology part. You need to ensure that all your engineering part and the principles are kind of aligned over there, right? So this is typically if you are looking forward towards your DevOps career. So I'll share the link as well, right? So to have a deep.
Yeah, so next question is what are the best online books or certification to master scalable web development?
So, well, I'm not much a fan of certifications, but what I'm trying to put across is that whenever you're sitting in the industry, what actually would matter is how much practically you have worked on the projects, right? So there may be a scenario that you don't have a project to work in your company, but if you try to look forward and maybe you intern some manager or you find someone who is having a good expertise and you're trying to intern them on their projects, that can be more valuable as compared to your certification, because people in the industry are not just looking forward for the certificates, they are looking forward for how much practically you can go ahead with it, right? But yes, of course, there are various platforms available. You can have the certifications. I just don't want to label them across over here.
Okay, so next question is what industries have the highest demand for scalability experts?
Yes, when it comes to the scalability part, right? So industry has a huge demand, and this is pretty much with the enterprise companies, right? So if you see, I'll just try to give a name, right? So there is a company called Off Business. I don't know how many of you know about it, right? So it's a company which has a revenue of turnover of 32,000 CR, right? So they need to scale their solution. So every company who is on an enterprise part, right? So they need to scale the solution. And that is where you have the right job fit. So it has a huge demand.
Okay,
And
so
it also comes along with the bigger package. So you need to also understand, right? So as a developer, if I'm able to write front end, back end, and if I am able to handle this Kubernetes and the scalable thing, so my package is also gonna go up.
so our last question is what challenges did you face while scaling applications at a huge e-commerce platform like Amazon?
All right. So I have worked on various different products in my own time, right? So if I talk about my career stack, right? So I worked with Samsung R&D, where I have worked on Galaxy S series, right? Starting from S1, S2, and then S3, even Note series 1, 2, and 3. So at that point of time, there was nothing like scalability for me when I was in my career track. But now, as an entrepreneur, when we are doing the consultations, right? So we have given the kind of consultations to Dell R&D. We have trained their set of team that how you can leverage a pivotal Kubernetes service, right? And then you can deploy the Kubernetes cluster for your solutions. Now, the pretty much simple example which I have given is, right, uh, for any enterprise solution, it doesn't matter that it's in e-commerce domain or it is in the domain of maybe let's say Blinkit scenario or any other e-commerce, right? So this can also come when we are talking about Zoom, right? So as of now, we are having a Zoom call, right? So Zoom doesn't know how many sessions at one single time gonna come up, right? So the scale can go up and down anytime. So for me in my journey, right, so I have handled some internal projects, right, where we have implemented the Kubernetes, and this was pretty much done using the Pivotal Kubernetes service, which is a product from the VMware. But yes, I just hope that all of you would try to deep dive into this technology and have a better package moving ahead.
Yeah, so we are done with our Q&A round as well. Okay, so thank you so much, Ishant, for that incredible session. I'm sure everyone has gained valuable insight into building a scalable web application. It's been an amazing learning experience, and we truly appreciate your sharing your knowledge with us. A big thank you to everyone who joined today. Your participation and engagement made this session even more insightful. We hope you found the session helpful and will be able to apply the knowledge shared. If you have any further question, feel free to reach out to us or connect with Ishan. Don't forget the session recording will be available on YouTube and LinkedIn for you to revisit anytime. We hope to see you in future session. Have a great day everyone and happy learning.
Thank you all. Thank you all. Rise and shine.
Bye.